Okay, now let's have a detailed discussion of addition polymers. So now the topic for this particular session is going to be addition polymers. So now we are going to study different addition polymers. So let's start with polyethylene. Okay. Now for polyethylene, let's start with the monomer. So monomer is going to be ethene. Okay, and then let's try doing the reaction. So there is a very easy way to remember. So you have CH2 double bond CH2, correct? So N such molecule. So what exactly happens? So this polymerizes. So first write down the molecule. First check whether it's multiple bonded system. It definitely has to be, because we are studying addition polymerization. Okay, then put everything with a single bond. Now this is going to undergo free radical reaction, right? So what happens is one radical will come here, one radical will come here, so that this will form one bond, this will form one bond. So now this is going to be the chain, the unit which is going to repeat. So this is going to repeat n times. Okay, so this is nothing but polyethylene. Okay, so now polyethylene is of two types. So the first type of polyethylene is LDPE. You call it as low density polyethylene. Now, what is low density? Low density polyethylene is basically obtained due to free radical reaction. Okay, we will be discussing, you could find different articles related to LDPE synthesis, or it's pretty much simple. You have a free radical chain going on, so hydrogen atom abstraction would be there, and then one more ethene molecule gets attached to it. So we'll be discussing this anyway. So it follows a free radical reaction, and the temperature for this reaction is greater than 350 Kelvin, and the pressure is 2000 atmosphere. Now low density polyethylene is generally used in wires and electrical instruments. Okay, now the next is high density polyethylene. Definitely the structure is going to be the same structure of the polymer. Okay, now the next is HDPE. You call it as high density polyethylene. The same thing. The structure of the polymer is going to be the same as well. The temperature for this reaction is around 333 to 343 Kelvin, and we used Ziegler-Natta catalyst, which is basically a mixture of TiCl4 plus triethyl aluminium. Okay, so and it is used in buckets and all those plastic items which we have been using. Okay, now the next is okay, now what about the properties? So properties, all polymers, they are so the properties, I would say the common property which is shown by all these is resistant to acids and alkalis, most of them, and then it is chemically inert. Okay, and then you could say that this is homopolymer. Low density is mainly, you could say, branched polymer, but it depends. So now the next is you have okay, I'll leave the name which is blank. Okay, the monomer is going to be CF2 double bond CF2. So this is nothing but tetrafluoroethylene. Okay, so tetrafluoroethylene is this, and then you could say that n such molecules, then you have polymerization delta, and this is carried out in inert atmosphere. So as I've already discussed, first write down CF2, CF2, this is nothing but the repeating unit, put one bond here, and then you have N. So this is nothing but the polymer. The name of the polymer is polytetrafluoroethylene, and you call it as Teflon. Okay, now let's see the properties. Resistant to acids and alkalis, chemically inert, and it's a homopolymer. And something which you are supposed to remember, it's the use. So this is used in non-stick cookwares. Okay, and this is heat resistant as well. So whenever you are cooking, many times your food gets stuck to the pan. So when it is coated with Teflon, it doesn't stuck. Then the next is the next polymer. Of course, it is a homopolymer, linear polymer as well. Then you have the next is I would leave the name blank. So the monomer is something like this: CH2 double bond CH. This is vinyl group, and then you put a cyanide here. So the monomer is acrylonitrile. Okay, so now let's write down the polymerization reaction. So the first rule is write n such molecules. Then you write the molecule without the double bond. Now what is going to happen? So this is the place where you have the double bond, right? So now what happens is this undergoes homolytic fission. So it forms one bond from this side, one bond from this side. Then this is a repeating unit. How many times it gets repeated is n time. So you get n, right? So this is polyacrylonitrile. Okay. So now the name of this polymer is PAN. Now again, the properties, it's a homopolymer, it's a addition polymer. You could say that it is linear polymer. We would consider an alkyl group as a branch rather than cyanide. If it is so, then it's a linear polymer. Otherwise, you could consider it as branch polymer. And then the most important aspect is the use. So it is resistant to acids and alkalis, chemically inert, and the use is it is used in colors. So you could say it is used in paints. You might be knowing about acrylic colors, and then it is used in colored lenses. Okay, then you have the next polymer. So the next polymer is going to be something what you have been using it, that is polypropylene. So polypropylene, what exactly do you mean by polypropylene? So as the name suggests, propylene is going to be the monomer. So the monomer is propylene. Prop means 3 carbons. So you have something like this. You have CH3, then you have CH double bond CH2. So now I'm going to orient this molecule in a different manner. So I would write CH3, then you have CH, then you have double bond CH2. So n such molecules. So what exactly happens is, first I would put an arrow, then I would put delta and N2, that is inert atmosphere. Then write down CH3, then you have CH, you have CH2, all with a single bond. So one bond from this side, one bond from this side, and then this is a repeating unit. How many times it has got repeated? It is n. So this is nothing but polypropylene. So this polypropylene is again a branched polymer. It's an addition polymer. It is resistant to acids and alkali. It is a homopolymer. It is chemically inert, and the use is it is used in Bisleri bottles. So you might be knowing that you just use the bottles, you crush it and throw it off. It is all because of this branch polymer, because of which it is easy to break. Okay, so this was about the next polymer. Then you have the other category of polymer, that is let me use the space here. So you have PVS. So VS, this is nothing but polyvinyl styrene. Okay, so now let's just write down the structure of styrene. Styrene is nothing but benzene ring. Okay, this is connected to CH, then you have double bond CH2, right? So now what exactly happens? You have N such molecules. So now how this would undergo polymerization? I would use the space down. So I would simply write C6H5. This is connected to CH, single bond CH2. This is something which I have already told. This is the single bond. So one bond from this side, one bond from this side. You have a bracket like this. This is a repeating unit. How many times it gets repeated? This is N. So this is polyvinyl styrene. Okay, mostly you have this group, you call it as a vinyl group, right? So it's definitely not necessary to use the word vinyl. In this case, you could simply write it as polystyrene, because when you are talking about vinyl, this is nothing but vinyl benzene, something like that. So it would not be a good idea to use polyvinyl styrene, something like this. So it is nothing but polystyrene. Okay, so I would just remove this word vinyl group. So it is vinyl benzene, but definitely I would not call it as vinyl styrene. Okay, then you have what is the uses? Uses, it is used in what do you say, cabinets, and you could say that different polymers are made of polyvinyl styrene. Okay, then you have the next is the next polymer is going to be something which we have been using in pipes. So it is polyvinyl chloride. So the structure of vinyl chloride is CH2 double bond CH, and then you have a Cl. So now let's try to write down the polymer now. So N such molecules, and you have delta, you have N2. So now what exactly happens? So this is the double bond. So concentrate on the double bond. First write down everything with a single bond. Okay, then one bond from this side, one bond from this side, and then this is a repeating unit, N type. This is polyvinyl chloride. Okay, so this is used in pipes, electrical pipes. This is used in sealants. This is used in raincoats. So it has multi-purpose uses. So this was all about the different types of addition polymers, out of which I have already said this is nothing but polystyrene, because this is a vinyl group attached to benzene. So we could not call it as vinyl styrene. So it is vinyl benzene basically. So polystyrene is the name of this particular polymer. So these are nothing but the addition polymers. So the most important aspect which you are supposed to remember for addition polymer is that they are generally, most of them are homopolymers. There are few heteropolymers or copolymers as well, and in this, all these compounds, they contain a double bond. They could be branched, they could be linear, depending upon what exactly the monomer is. And all these polymers are resistant to acids and alkalis. They are chemically inert. Some are heat resistant, thermally resistant. Most of them are, what do you say, heat resistant.